We have already discussed or seen the integration of transforms. What do you mean by integration of Laplace transforms? Integration of transforms means if L of f of t is equal to Laplace transform of a function f of t is equal to f of s, then L of f of t by t is equal to integral s to infinity f of u du. F of t transform f of s ayal f of t by t transform integral f of u dy. That is integration of transforms. What is differentiation of transforms? Differentiation of transforms means if L of f of t is equal to f of s, then L of t raised to n into f of t is equal to minus 1 raised to n into n the derivative of fs. Or if n is equal to 1, we have if L of f of t is equal to f of s, then L of t into f of t is equal to minus f dash s, minus derivative of fs, that is minus f dash s. Okay? This is f of t transform f of s. Then f of t by t transform integral f of s. Okay? Then property apply that we have already seen one problem or discussed one problem. Now consider this problem. Find the Laplace transform of sin a t by t and f of t by t. If we take this as f of t by t, then what is f of t? Sin a t. Now let f of t is equal to sin a t. What is L of f of t? L of f of t means L of Laplace transform of sin a t. Sin a t Laplace transform is equal to a divided by s square plus s square. It's okay, equal to capital F of s. Then f of t transform is f of s. Hence, by integration of transforms, L of f of t by t, Laplace transform of f of t by t is equal to L of f of t by t is equal to Laplace transform of f of t means sin a t by t, and sin a t by t is equal to integral s to infinity f of u du. F of s is equal to a divided by s square plus s square. F of u means put u instead of s. Then that is equal to integral s to infinity a divided by f of s square plus s square more than a divided by u square plus s square into du. F of u du is equal to what is integral dx divided by x square plus s square. Dx divided by x square plus s square is equal to 1 by a into tan inverse x by a. Therefore, du divided by u square plus s square is equal to 1 by a into tan inverse u by a. Now, property apply here. That is a in outside a into integral du divided by u square plus s square is equal to 1 by a tan inverse u by a. Or integral a divided by u square plus s square is equal to du is equal to tan inverse u by a. Then a into 1 by a cancel a. That is tan inverse u by a between the limits s to infinity. Now upper limit apply here. Upper limit apply upper limit apply the tan inverse infinity. Now tan inverse infinity minus u is equal to s lower limit tan inverse s by a. What is tan inverse infinity? Tan pi by 2 is equal to infinity. Sin pi by 2 by cos pi by 2 infinity. Therefore tan inverse infinity is equal to pi by 2. Pi by 2. That is Laplace transform of sin a t by t f of t by t is equal to pi by 2 minus tan inverse u in bar s കൊടുത്താൽ f by a. That is Laplace transform of sin a t by t f of t by t. Similarly, we consider cos a t by t also. ഇതേ മാതിരി തന്നെ ചെയ്യാം. ഇത് മനസ്സിലായില്ല. അതായിരിക്കണം f of t by t എന്നൊരു പ്രോബ്ലം കിട്ടിയാൽ t into f of t ആണ്. t into f of t ആണെങ്കിൽ ഡിഫറൻസിയേഷൻ പ്രോപ്പർട്ടി. f of t by t ആണെങ്കിൽ എന്തായിരിക്കുന്നത് ഇന്റഗ്രേഷൻ പ്രോപ്പർട്ടി അപ്ലൈ ചെയ്യുക. അതിന് സൂട്ടബിൾ ആയ ഒരു ഫംഗ്ഷൻ f of t സെലക്ട് ചെയ്യും. Then apply the integration property. ഇതൊന്ന് സേവ് ചെയ്യുക. സേവ് ചെയ്തിട്ട് നോട്ടിലേക്ക് മാറുക. ഒന്ന് സേവ് ചെയ്യും. Laplace transform of sin a t by t. F of t is equal to cos a t. That means that the given problem is cos a t by t means f of t by t. And what is Laplace transform of f of t? L of f of t is equal to L of cos a t. Laplace transform of cos a t is equal to s divided by s square plus s square equal to f of s. Then f of t with the transform f of s. Hence, by integration of transforms, L of f of t by t Laplace transform of f of t by t means Laplace transform of cos a t by t is equal to integral s to infinity f of u du. F of s is equal to s divided by s square plus a square. Then f of u is equal to u divided by u square plus a square. S വരുന്നത് u. Instead of s, take u. Then that is equal to integral s to infinity f of u du. F of u divided by u square plus a square into du. That is answer. Then to integrate this one, integral let u square plus a square is equal to t. Denominator u square plus a square is equal to t. Then differentiate derivative of u 2u into du. U square derivative 2u into du is equal to dt. Then what is du? U du is equal to u du is equal to dt by 2. And the consider limit also. Limit means when u is equal to s. Here s to infinity u divided by u square plus a square u du means u varies from s to u is equal to infinity. And when u is equal to s, complete variable is converted to t. The s varies then says corresponding item. What is the variation of t? Then when u is equal to s, we have t is equal to u in various order s square plus a square, s square plus a square. Now when u is equal to s, t is equal to s square plus a square. And again when u is equal to infinity, upper limit. When u is equal to infinity square plus a, that is t is equal to infinity. That is integral 1. Integral s to infinity u du by u square plus a square is equal to integral s square plus a square to infinity. Now, s square plus a square to infinity u du. What is du? U du is equal to dt by 2. That denominator s square u square plus a square is equal to, what is u square plus a square? Is equal to t. That is integral s to infinity u du by s square plus a square is equal to integral s square plus a square to infinity. U is equal to s, then t is equal to s square plus a square. Integral s square plus a square to infinity dt by 2 into t. U du is equal to dt by 2 into s square plus a square is t. That is equal to 1 by 2 in outside the 1 by 2 into. What is integral of 1 by 2 dt? 1 by 2 dt integral 1 by x dx is equal to log x. 1 by t dt is equal to log t, which will be the limits s square plus a square to infinity. Then apply the limits. That's equal to, that's 1 is equal to, this result is equal to 1 by 2 into log of infinity, upper limit apply minus t is equal to s square plus a square with the log of s square plus a square, log infinity minus log s square plus a square. Or Laplace transform of 1 means the L of cos a t by t. Laplace transform of cos a t by 2 is equal to log infinity is equal to 0. Then minus 1 by 2 log of s square plus a square. That is log infinity is equal to 0. And sin a t by t, similarly Laplace transform of cos a t by t. Cos a t by t is equal to minus 1 by 2 log s square plus a square. This is important. This is save it and not like save it. Consider another very important result. A very important result. See, what do you mean by differentiation of transforms? Differentiation of transforms means if L of f of t is equal to f of s, then L of t raised to n into f of t is equal to minus 1 raised to n into nth derivative of fs. If Laplace transform of L of f of t is equal to f of s, then L of t raised to n into f of t is equal to minus 1 raised to n into nth derivative of d raised to n divided by ds raised to n of fs. Or let n is equal to 1. N is equal to 1 if L of f of t, Laplace transform of a function f of t is equal to f of s, then Laplace transform of t into f of t. T raised to n is t raised to n is equal to 1. T into f of t is equal to minus 1 raised to 1. That is minus d raised to n is d divided by ds of f of s. Or if L of f of t is equal to f of s, then L of t into f of t is equal to minus derivative of fs. Derivative of fs d divided by d of s of fs means d divided by dx of fx f dash x. Similarly, d divided by ds of fs means minus f dash s. F dash s, first derivative of s. Okay? And then if L of f of t is equal to f of s, then L of t into f of t is equal to minus f dash s. Okay? Then consider another very important corollary or not. This one. Okay. If L of f of t is equal to f of s, then is what is L inverse of f of s is equal to f of t. Using differentiation of transforms, we have this property apply here. If L inverse of fs is equal to f of t, L of f of t is equal to f of s means L inverse of fs is equal to f of t. If L inverse of fs is equal to f of t, ഇതിന്റെ inverse ഇതാണ്. ഇതിന്റെ transform f of s ആയാൽ inverse എന്തായിരിക്കും? If L inverse fs is equal to f of t, then L inverse of f dash s, L inverse of derivative of f, L inverse of f dash s is equal to ഈ മൈനസ് ഇപ്പുറത്തേക്ക് എന്നാൽ മൈനസ് t into f of t. അല്ലേ? ഇതിന്റെ ട്രാൻസ്ഫോം ഇതാണെന്ന് പറഞ്ഞാൽ ഇതിന്റെ ഇൻവേഴ്സ് എന്തായിരിക്കും? ഇതായിരിക്കും. That is, if L inverse of fs is equal to f of t, then L inverse of f dash s is equal to minus t into f of t. Fs inverse f of t, then f dash s inverse is equal to minus t minus ഓടെ പുറത്തേക്ക് കൊണ്ടുവന്നാൽ divided by means multiply by minus t into f of t. Okay? That is, if L inverse fs is equal to f of t, then L inverse of f dash s is equal to t into f of t. What is f of t? L inverse of fs. That is, L inverse of f dash s is equal to minus t into f of t. What is f of t? L inverse of fs. And then L inverse of Laplace inverse of f dash is equal to minus t into L inverse of fs. Okay? Laplace inverse of f dash is derivative of f dash in the inverse. So the derivative of f in the inverse is minus t into f in the inverse. Well, but L inverse of f dash is equal to minus t into f of t. F of t is equal to L inverse fs. That is, L inverse of f dash is equal to minus t into L inverse of fs. Then t would have therefore, L inverse of fs is equal to, what is L inverse of fs? E t would have minus 1 by t into L inverse of f dashes. Okay? Laplace inverse of a function f of s is equal to minus 1 by t into Laplace inverse of f dashes. A very important result. Laplace inverse of fs is equal to, what is Laplace inverse of fs is equal to minus 1 by t into Laplace inverse of f dashes. Laplace inverse of f dashes. This way. Laplace inverse of fs is equal to minus 1 by 2 into Laplace inverse of f dashes. This is the result. This is the inverse. F dashes is the inverse of minus t into f of t. Laplace inverse of f dashes is equal to minus t into Laplace inverse f of t means Laplace inverse of f dashes f of s. Or Laplace inverse of fs is equal to Laplace inverse of a function is equal to minus 1 by t into Laplace inverse of its derivative. Laplace inverse of a function f is equal to minus 1 by t into Laplace inverse of its derivative f dash. This is a very important one. This is very important note. Laplace inverse of a function is equal to minus 1 by t into Laplace inverse of its derivative. Or Laplace inverse of f of s is equal to minus 1 by t into Laplace inverse of f dash s. So get the save with it only. Very important note. I have told you. What was that? L inverse of a function f of s, Laplace inverse of fs is equal to minus 1 divided by t into L inverse of f dash s. L inverse of fs is equal to minus 1 by t into L inverse of f dash s. That means to find the Laplace inverse of a function involving log. For example, log of 1 divided by s square plus I square, log of s square plus I square, log of the table. Similarly, to find the Laplace inverse of a functions involving inverse trigonometric functions. For example, tan inverse 1 by s, sin inverse 1 by s, or sin inverse s, etc. from logarithm inverse of functions in the Laplace inverse to find the Laplace inverse of, especially in logarithmic functions and inverse trigonometric functions, we apply this property. That means another problem in the area. Find the Laplace inverse of log or function. അല്ലെങ്കിൽ sin inverse, cos inverse, tan inverse 1 by s, tan inverse x, etc. Logarithm to inverse trigonometric functions in the Laplace inverse, we apply this property. That is what is Laplace inverse of fs is equal to minus 1 by t into Laplace inverse of f dashes. We consider this problem. Find Laplace inverse of tan inverse 1 by s. See, what is this function? Inverse trigonometric function. Instead of this, if the function is logarithmic function 1 divided by log of 1 divided by s plus a, etc. There also you apply this property. There are logarithmic function, inverse trigonometric function, Laplace inverse we apply this very important part. The Laplace inverse of fs is equal to minus 1 by t into Laplace inverse of f dashes. Let this is equal to f of s. Let f of s is equal to tan inverse 1 by s. We have to find Laplace inverse of tan inverse of 1 by s means f of s. Tan inverse of f of 1 by s means f of s means Laplace inverse of fs. Now let f of s is equal to tan inverse 1 by s. Then what is f dashes? F dashes means derivative of fs. D divided by ds of fs. That is d divided by ds of tan inverse 1 by s. What is the derivative of tan inverse x? Derivative of tan inverse x is equal to 1 divided by 1 plus x square. So again, d divided by derivative of d divided by du of tan inverse u. Tan inverse u is equal to 1 divided by 1 plus u square. 1 divided by 1 plus u square. Tan inverse x derivative is equal to 1 divided by 1 plus x square. That is tan inverse of 1 by s derivative 1 divided by 1 plus 1 by s in the square. 1 divided by 1 plus u square. And again, derivative of this u. Tan inverse is 1 divided by 1 plus u square. What is derivative of u? Derivative of u means 1 divided by s derivative. 1 divided by s derivative minus 1 by x square. Tan inverse 1 divided by 1 plus u square. Tan inverse of u. Tan inverse of u derivative is equal to 1 divided by 1 plus u square. Then 1 divided by 1 plus u here, 1 by s in the square. Into derivative of u. Derivative of u means derivative of 1 by s is equal to minus 1 by s square. That this is equal to 1 divided by 1 plus 1 by s square. Cross multiply the 1 divided by 1 plus s square plus 1 square divided by s square. 1 divided by s square plus 1 divided by s square. S square numerator. Then 1 divided by that is equal to s square divided by s square plus 1 square. This is 1 plus 1 by s square. Cross multiply the s square plus 1 all divided by s square. Then s square plus 1 all divided by s square. S square numerator. That is equal to s square divided by s square plus 1 square into this minus 1 by s square. S square cancelling. That is derivative f dash s is equal to minus 1 divided by minus 1 divided by minus 1 divided by s square plus 1. So again, that is f of s is equal to tan inverse 1 by s, then f dash s is equal to minus 1 divided by s square plus 1. Then apply this property. So what is L inverse of f dash s? L inverse of f dash s means L inverse of minus 1 divided by s square plus 1 square is equal to minus 1 divided by s square plus 1 square is equal to a divided by s square plus a square is equal to sin a t. 1 divided by s square plus 1 square is equal to minus sin t. A is equal to 1 minus sin t. That is L inverse of f dash s is equal to minus sin t. Then what is this not? L inverse of fs, hence by the above not This is very important selection. L inverse of Fs is equal to L inverse of Fs is equal to minus 1 by 2 into L inverse of F dashes. That is L inverse of what is Fs? Tan inverse 1 by s is the given problem. That is L inverse of tan inverse of 1 by s. L inverse of Fs is equal to minus 1 by t into L inverse of F dashes. What is L inverse of F dashes? L inverse of F dashes is equal to minus sin t into minus sin t. That is minus into minus plus sin t by t. Or Laplace inverse of tan inverse of 1 by s is equal to Laplace inverse of tan inverse of 1 by s is equal to sin t by t. Second. L inverse Fs is equal to minus 1 by t into L inverse of F dashes. This property we apply already to find the problems to find the Laplace inverse of problems involving logarithmic functions and inverse trigonometric functions. Logarithm inverse trigonometric tan inverse 1 by s, sin inverse 1 by s, cos inverse 1 by s, cot inverse x, etc. Inverse trigonometric functions and also logarithmic functions. Log s plus 1 divided by s minus 1, log 1 divided by s. We apply this method. Laplace inverse of Fs is equal to minus 1 by t into Laplace inverse of F dashes. F of s F dashes, L inverse F dashes, then L inverse Fs is equal to minus 1 by t into L inverse of F dashes. This is very important. This section is very important. Logarithmic inverse. Very simple property apply. This problem is property. This is the save note. Okay. Now, we section theory. Third module, Laplace transform and its applications and property. This is the same note.